So this is an exponential type question where we have e here. So I'm assuming you've read the question, you've attended the question, so I'm just going to just jump into the explanation. To find the value of k, we need to use this fact that they gave us. So we have p of 1 divided by p of 0. Well, p of 1 is basically just substituting 1 for t. So I have p of 0 e to the power of k and then times 1. And so I can substitute this into my numerator here. So p of 1 is going to be p of 0 e to the power of k divided by p of 0, and it should be equal to 0.9. And from the beginning, you might be wondering, well, we don't know p of 0. Well, it doesn't matter because it's going to cancel out here. So I'm left with e of k is equal to 0.9. And you're going to log this, but not using log, you're going to use the natural log. So ln of e to the power of k is equal to 0.9, and you should be very practical with this. K becomes a coefficient, ln of e is equal to 1, so k is equal to, you take the log of both sides, and you have 0.9. You can leave it as such, you can find the value, but when you are solving the rest of the question, keep it as a ln of 0.9 because it's going to keep it as an accurate answer. So this is for part A. As for part B, it tells you, for part II, so this is ln 0.9. For part II, it tells you interpret the meaning of the value of k. Now the value of k is a negative 0.105. Now a negative power means that you are decaying, and this is a property of exponential functions. Or you can graph it and see what it tells you. Because the t is going to keep on increasing, doesn't matter, but with a negative power, doesn't matter how big t is, you'll always multiply by a negative number. So what's happening is that there's always a decrease. So you have a decay in growth, or you can say population decrease. Okay, so this is an interpretation. Now for part B, find the least number of whole years for which p of t over p of 0 is less than 0.7. So we have that p0e ln 0.9 of 2, sorry, not of 2, of t divided by p of 0. We want this to be less than 0.75. So again, the p of 0's will cancel out, and you are left with e ln of 0.9 t less than 0.75. We've done an example like this before, where e to the power of ln of 0.9, remember that e to the power of ln is 0.9 is the same as e to the power of log of base e, 0.9, and if your base here and the base of the log are the same, all you take is this. So this becomes, the argument becomes the answer. So this whole thing is raised to the power of t, and this whole thing is actually equal to 0.9. So it's 0.9 to the power of t less than 0.75. So we're going to follow the same process in terms of finding the power. We're going to take the log or the ln of both sides. So we're going to have ln of 0.9 less than the ln of 0.75. Now, you want to divide by 0.9, but be careful. Whenever you're dividing by a number less than 1 with logs, you are actually dividing by a negative number. And the rules for inequalities is that if you're dividing by a negative number, you have to flip the inequality. So just be aware of this whenever you're dividing by logs. Just make sure that your division is a positive or a negative. Just double check if it's a positive or a negative number. Generally, or by a fact, anything less than 1 is going to be a negative answer. It's going to be a negative log. So we have to switch the inequality here. The answer is going to be that the time has to be bigger than 0.7. Sorry, not 0.7. It has to be bigger than 2.73. Now, bigger than 2.73, so this, keep in mind that t is measured in decades, and the answer has to be in years, not in decades. And we want the least number. So if I pick 2, this would be too low. It won't reach 0. It will actually be more than 0.75. So you can test out the numbers if you want to, as in if you pick 2 decades. So 2.73. So 2.73 in terms of decades is 27.3 years. But if I just pick 27, because we need whole numbers, so if I round down, 27 is going to be too low, and I won't reach the value that I need. The ratio won't be less than 0.75. It will actually be more, which means my t has to be equal to 28. So you will not be substituting 28, because remember t is in decades. You will be substituting 2.8. So if you actually try out substituting ln of 0.9 times 2.8, the value is going to be, let's try it out, ln 0.9, 2.8, the value is going to be 0.74, which is precisely less than 0.75. If I try 2.7, then it wouldn't work. But keep in mind that it had to be a whole year, so this is the answer. This was another log question. So for part A, find the vertical asymptotes. The vertical asymptotes in logs occur when the log is equal to 0, which is undefined. So remember, your vertical asymptotes are when the things that are not allowed in your domain. So what's not allowed in the domain is for x to be equal to 3, and it's already kind of giving you a hint. So the vertical asymptote is just going to be x equals to 3. Or you can think of it as, well, the -3 is a shift to the right by 3. So if the vertical asymptote is meant to be at 0, then a shift to the right by 3 is going to make the vertical asymptote x equals to 3. Now for the x-intercept, you are going to have, the x-intercept occurs when y is equal to 0. So you want your function equals to 0. So 2 ln of x minus 3 equals to 0. And divide by 2 on both sides. And then the only time your log is going to be equal to 0 is if your argument is equal to 1. So, or you can try and rewrite ln as log of e x minus 3 equals to 1, and then do e to the power of 1 equals x minus 3. That's the long route. But I know that the argument has to be equal to 1, so x minus 3 has to be equal to 1. And so x equals to 4, and you can test out. So the x-intercept is x equals to 4. Now the rest part of this question was about finding the area under the curve and rotation, but this is integration, so this is a common follow-up question where they ask you for the area under the curve, but that's for the calculus section.